Hello friends, today I am going to discuss about M.O.T. Myself Dr. V.R. Dangar, M.B.M Science and Home Science College, Rajkot. So first off, what is M.O.T? Probably second and most applicable theory for bonding and structure of molecules. Put forward by Hund and molecular scientists, later modified by Jones and Coulson. So here is Hund and molecular scientist. Why M.O.T? Through there was VBT to explain bonding and structure of molecule, still it was unable to explain some features. Hence, because of the drawbacks of VBT, another theory was given, known as molecular orbital theory or M.O.T. Full form of M.O.T. is molecular orbital theory. Drawback of VBT: fails to explain paramagnetic nature of O2. Resonance plays a major role in VBT, but no role in M.O.T. VBT did not give any weightage to ionic structure, but M.O.T. did. It didn't say about anti-bonding, thus failed to say about spectral lines. Principle of M.O.T. Molecular orbital theory. Any number of atomic orbitals overlap to form molecular orbitals. An equal number of molecular orbitals are formed. When two s orbitals overlap, they form two new orbitals, one at lower energy than the original s orbitals and one at higher energy than the original's orbital. So, M.O.T. according to M.O.T, the nuclei of the two atoms lie at appropriate distance and all the atomic orbitals of one atom overlap with all the atomic orbitals of the other atom, provided the overlapping orbitals are of the same symmetry and of similar energy. The resulting molecular orbitals are polynuclear and contain all the electrons of the molecule. M.O.T. depends on following basic principles. So, first principle, basic concept of M.O.T. here. M.O. theory is proposed by Mulliken and Hund in 1930 and extended by I.E. Leonard Jones and Charles Coulson. So, according to M.O. theory, the probability distribution of an electron around a group of nuclei in molecule is indicated by a molecular orbital or M.O. And second concept, the electrons are filled in these molecular orbitals on the basis of A.B.M.O principle, Pauli's principle and Hund's rule. Same way used Pauli, A.B.M.O and Hund's rule in hybridization. And third is the molecular orbitals have definite energy levels. Fourth, the shape of M.O.'s molecular orbitals form depend upon the shape of combining atomic orbitals. Fifth, according to the principle of wave mechanics, a molecular orbital is constructed by the linear combination of atomic orbitals in full form of LCAO. L means linear combination of atomic orbitals of two atoms between which a bond is formed. And last, the numbers of molecular orbitals formed are equal to the number of atomic orbitals participated in the overlapping. Now let's see characteristics of molecular orbitals. First is B.M.O. Full form of B.M.O is bonding molecular orbitals. So what is B.M.O? Whenever there is addition of wave function, it is symmetrical orbitals overlaps, then there is high electron density between two nuclei. Therefore, such type of molecular orbitals having lower energy than both atomic orbitals and is known as bonding molecular orbital B.M.O. The linear combination of two atomic orbitals have wave functions is brought about either by adding or by subtracting them. The bonding molecular orbitals are shown by sigma and phi. Its formation takes place when the lobes of atomic orbitals have same signs. For example, SS orbitals and PX orbitals can also combine in a similar way along internuclear axis to form B.M.O. So here 1s and another 1s orbital when combined to each other and form two B.M.O. One is sigma 1s and one is sigma star 1s. So here sigma 1s is bonding and sigma star 1s is anti-bonding. So in anti-bonding there is a nodal plan, and in bonding molecule there is no nodal plan. So here when 1s and 1s orbitals combine in similar way along to internuclear, here two B.M.Os are formed. So here also another example, when 2s orbitals combine with each other to form here sigma 2s and sigma star 2s. Here sigma 2s is bonding molecular orbital and sigma star 2s is anti-bonding molecular. Here nodal plan is present in anti-bonding molecular always, but in bonding molecule there is no nodal plan. So same way when PX combination to form here two M.O 2p when combined to each other and B.M.O sigma 2p, and here sigma star 2p anti-bondings are formed. Same here py and pz also M.O two M.Os are here formed, pi 2p and pi star 2p. Here why pi bonds are formed? Because here internuclear axis sidewise overlapping is here. So when sidewise overlapping there is pi bond formed, and when head to head overlapping there is always sigma bond is formed. So here head to head overlapping, so here sigma, and sidewise overlapping in py combination, so here phi. So in pi star 2p is anti-bonding, here one nodal plan is here. So these are all B.M.O are forms. Same things we consider, and let's start what is A.B.M.O. A.B.M.O's full forms: anti-bonding molecular orbitals. So whenever there is subtraction of wave functions, it is opposite orbitals overlaps, then there is negligible or zero electron density between two nuclei. Therefore, such type of molecular orbitals having higher energy than both atomic orbitals and is known as anti-bonding molecular orbital or A.B.M.O. The A.B.M.O are shown by sigma star and pi star. Its formation takes place when the lobes of atomic orbitals have different signs. So combination of s orbital here, one is s between two nuclei, electron density here increase, and sigma anti-bonding. Here a nodal plan is present. So this is anti-bonding orbitals when one s and another s combine to each other. And now similar px px py py orbitals when combinations. So here anti-bonding, here also anti-bonding orbitals are formed. Now let's discuss about third characteristic of molecular orbital is N.B.M.O. N.B.M.O full form means non-bonding molecular orbitals. For diatomic molecules obtained from atom having more than one electronic shell, the inner shells do not appreciably affect the bonding and may be omitted. Such inner electrons are called non-bonding electrons pair. Such type of molecular orbitals is having no change in energy than both atomic orbitals and is known as non-bonding molecular orbitals or N.B.M.O. Now fourth characteristics of M.O, sigma M.O and pi M.O. Sigma, here sigma M.O or pi M.O. So what is sigma M.O? Sigma M.O, it is formed by head-to-head overlapping of atomic orbitals. The overlap is along internuclear axes. As a result of this, strong bond is formed. The region of overlap is greater. For example, combination of SS and PX orbitals, there are always forms sigma M.O. In pi M.O, what is pi M.O? It is formed by the sidewise overlapping of Py or Pz atomic orbitals. The overlap is perpendicular to internuclear axis. So as a result of this, weak bond is formed. The region of overlap is lesser in pi M.O as compared to sigma M.O. For example, combination of SS orbital here, one s and another one s. So here sigma 1s B.M.O and sigma star A.B.M.O. So sigma M.O and sigma star M.O. Here also combination of PX head to head overlapping. So sigma PX means B.M.O and sigma star PX A.B.M.O. Same example when 2py or 2pz combination, there is a two possibility, pi 2py or pi star 2py or pi 2pz or pi star 2pz. Sidewise overlapping, same symmetry, there is always form pi bond, and opposite, if opposite sign, there is always form anti-bonding molecular orbital. So these are all examples are sigma M.O and pi M.O. Now let's see what is Gerade M.O in small g, and Ungerade M.O means small u. So what is Gerade and Ungerade M.O? When rotation of 180 degree is carried out about bond axis, if the signs of molecular orbitals or lobes of molecular orbitals do not change, they are called Gerade M.O. If there is sign of M.O, lobes of signs M.O change, it is called Ungerade M.O. For example, s orbitals. So what is shape of s orbitals? Spherical shape of s orbital. So s orbital is Gerade. In p orbitals, we know that shapes, dumbbell shapes. So in center, two lobes, one is positive and one is minus. So if we rotate 180 degree in p orbitals, there is change or lobe sign is changed. So p orbital is Ungerade. Same d orbitals. Are double dumbbell shape, so its sign is not changed. So d orbitals is Gerade. F orbitals shape is not known, or f orbitals are Ungerade. So here s, p, d, f orbitals are, we know how they are Gerade or Ungerade. So let's see examples. 2s orbitals. When combination of 2s orbitals, there are two M.O.s are formed. One is sigma 2s and one is sigma star 2s. So sigma 2s orbitals is Gerade. Why? So in Gerade's shape is spherical. So if we rotate 180 degree, there is no change of sign. So sigma 2s is always Gerade. And here sigma star 2s, if we in plan of sigma star 2s, if we rotate 180 degree, the here plus and minus signs are changed. So sigma star 2s is always Ungerade. Same when combination of 2px, here sigma 2px, if we rotate 180 degree, here minus, there is no change in sign, so it is Gerade. And here if sigma star 2px, if we rotate, so here sign is changed. So sigma star 2px is Ungerade. Same when combination of 2py and 2pz combination, here two M.O.s are formed, pi 2py or pi 2pz, or pi star 2py or pi star 2pz. So in pi 2py, when we rotate 180 degree, there is a sign is changed. So pi 2py or pi 2pz is Ungerade. But in pi star 2py or pi star 2pz, if we rotate 180 degree, there is no change, because here minus, or here plus, or here plus. So there is no change in sign in pi star 2py or pi star 2pz. So pi star 2py or pi star 2pz z is Gerade in. Thanks.